So the very last section that we're going to cover in our unit on equations is word problems. So you actually want to make use of some of the techniques for solving equations to solve word problems. Before we really get into solving any word problems, we want to look at some basic kind of concepts that hopefully you've encountered in your mathematical past as a student. So we're talking about like area of, let's say, a rectangle. This is a geometric concept that you often learn maybe 3rd, 4th, 5th grade. I say I have a rectangle. And you have two dimensions. You have a width, normally which we call the short side, and a length, which we often call the long side. And the area is basically the amount of space that covers the rectangle. We use the formula area equals the length times the width. The length times the width. This is always in square units. Square units. So for example, if you had a rectangle that were, 2 units by 3 units. Notice this one is 2 units. So the length here is 2, and the width here is 3. You basically say, okay, the area is what? 2 times 3, which is 6 square units. And you can see, you got 6 little squares here. That's kind of the idea. So area of a rectangle is the length times the width. And the units are in square units. What else? There's the area of a triangle. Area of a triangle. So if I take a triangle, we have this dimension called the height. The height. And this dimension called the base. The area of a triangle turns out to be 1/2 the base times the height. And this is also in square units. Anything else worth mentioning? We could talk about perimeter, maybe. Perimeter of a rectangle. So if I take a rectangle, and I call the long sides L and the short sides W, the perimeter is basically the distance all around the outside. So you take the 2 W's, add them together, the 2 L's, and add them together. So add all the sides together, and you're going to get the perimeter, P. The perimeter, we're going to use P for perimeter, is 2L plus 2W. And this is in units, not square units, but individual units. Let me see some other important formulas you should know. Okay, so let's say you're talking about the sides of a right triangle. Sides of a right triangle. So let's say I have a right triangle. So it's a triangle with one of the angles being a 90-degree angle here. We call this side A, and this side B, and this side C. So you have something that relates those 3 sides, called the Pythagorean theorem, the Pythagorean theorem, or the Pythagorean theorem in American English, Pythagorean theorem. And it says basically if you take A squared plus B squared, it's going to give you the hypotenuse. The hypotenuse is this side here across from the right angle, that side squared. So the sum of the squares of the 2 legs equals the square of the hypotenuse. And that can be useful. You're talking about the relationship between distance rate, which is speed, and time. This is a common idea that shows up a lot in math. So what's the relationship between distance, rate, and time? Well, speed or rate, so R is going to be rate or speed. D is going to be distance. T is going to be time. You think about it, a lot of times rate is measured in like miles per hour, right? Miles per hour. So you take miles on top, which is distance. And on bottom you have time. So miles would be on top and hours would be on bottom. So miles per hour. So distance over time. So rate equals distance over time, or you can multiply both sides of this equation by t. So I have that equation, I can multiply both sides by t like that. And notice how the t's cancel on the right side, right? T on top cancels with t on bottom, and you got d equals RT. So here's another way to write it, is d equal RT. Rate equals distance over time, or distance equals rate times time. Actually, this one's the most common version. Okay, so these are some common kind of relationships, mathematical relationships that you kind of encounter probably when you're from 3rd grade up till, I don't know, through high school. Hopefully you've seen most of those before. If you haven't, well then learn them, please. So we want to do some word problems involving some of these concepts. So my first problem involves a rectangular parking lot. A rectangular parking lot has a perimeter of 1,200 feet. The length is 100 feet more than its width. Determine the dimensions of the parking lot. So normally when I'm doing word problems, first of all, I read the problem and I make sense of it. I'll call this like step 0. Step 0, I read it, I make sense of it. So here I have a rectangular parking lot. We're going to have 2 dimensions, right? We're going to have width. We're going to have length. I like to call the long side the length, the short side the width. We know that the perimeter is 1,200 feet. The length is 100 feet more than the width. We want to find the dimensions of the parking lot. Okay, so step 2 here. Step 2. Or I should say step 1 actually, right? Step 1. Step 0 is making sense of the problem. Step 1 is going to be declaring my variables. So my variables are going to be those quantities that I'm looking for. So what am I looking for? I'm trying to determine the dimensions of the parking lot. So I'm looking for the length of the parking lot and the width of the parking lot. So I want to formally declare those things. So now step 2 is going to be to write my equations. And we're going to get those equations by reading our sentences carefully and coming up with mathematical relationships between our variables, length and width. So the very first sentence here, we have a rectangular parking lot has a perimeter of 1,200 feet. So our first equation, equation 1, that wasn't good. It's bugged out on me. Okay. Equation 1, I was writing equation 1 and when it bugged out on me. So the first equation in step 2 here is that the perimeter of a rectangle is 1,200, right? So perimeter of a rectangle, remember, is 2L plus 2W. So our perimeter equals 1,200. That's the first sentence. Okay, the second sentence gives us our second equation. So the length, that's L, is, this word is means equals, the length is 100 more than the width. What does that mean, 100 more than the width? Well, we're taking the width and adding 100 to it, right? 100 more than the width is 100 added to the width. So the length equals the width plus 100. Okay, so we got our two equations from the first sentence. We got the purple equation. The second sentence, we have the orange equation. The third sentence just asks us to find the dimensions, and we know we already have to do that, so that's not giving any equations here. The next step is to solve these equations. So I'll do a little step 3 where I solve. So notice I have a purple equation and an orange equation, and I have two variables, L and W. It would be nice if I can get this all in terms of a single variable. So what I'll do here, this W right here in the first equation, I can replace that, right? I can replace that with, no, not that one, I'm sorry. This L, I should say. This L right here in the first equation, I can replace that with W plus 100. I get my colors right. I'm going to have 2 times a blank plus 2W equals 1,200. So in place of that L, we had an L there, we're going to put W plus 100. And notice now that we only have a single variable in this equation, which is nice. If we want to clean this up, we want to distribute the 2. We're going to do 2 times W is 2W, plus 2 times 100 is 200, plus 2W equals 1,200. So altogether, we're going to have here 2W and 2W, that's 4W. 4W plus 200 equals 1,200. We can subtract 200 from both sides. And that'll give us that 4W equals 1,000. And then divide both sides by 4 to get W by itself. And we'll end up with W is 250. Right? 1,000 divided by 4 is 250. And I think here we're talking about feet. So that gives us only one of our dimensions. Remember, we wanted to find the length and width. So we have the width, so how do we find the length? Well, what we know is that the length is 100 more than the width. So here I can plug in right here. For W, I can plug in 250, and we'll get that the length is 250 plus 100. In other words, the length is 350 feet. And it's always a good idea to go back and check your work, make sure this all checks out. So remember that in the problem that the length was 100 more than the width, is that right? Is the length 100 more than the width? Yeah, right, the length is 350, the width is 250, so the length is 100 more than the width. Is the perimeter 1200? Let's see, the perimeter. Let's just check this. Is perimeter equal to 1200 feet? Remember the formula for perimeter, it's 2 times L plus 2 times W. Let's see if this equals 1200. So we're going to have 2 times 350 plus 2 times 250. It's going to be 700 plus 500. That's equal to 1200. Yeah, so it checks out. Do you have to check it? You really don't, but it's always a great idea, at least mentally. If you're not going to do it on paper, do it mentally to make sure that your problem makes sense. Your answer to your problem makes sense. No. Okay, so that's my first word problem. I'm going to do a second word problem. Another one having to do with kind of geometric type things, but this time rather than perimeter, I'm going to do an area of a triangle. So here's number 2. A triangle has an area of 20 square centimeters. The base is 6 centimeters less than the height. Determine the base and height of the triangle. Okay, so we want to read this and make sense of it. I'll call that step 0. Make sense. So in this case, we very clearly can draw a picture. So let's do that. We have a triangle. And it says that the base is smaller than the height, right? The base is 6 less than the height. So we're going to have a taller height this time. So I'm going to have a tall triangle with a small base. So this here is the base right here. We're going to call that B. And this here is going to be the height, H. So the area is 20 square centimeters, and the base is 6 smaller than the height. We want to find the base and the height. The base and height. So we want to declare our variables. That'd be step 1 officially, I guess. So I'm going to call the base B and the height H, right? Those are the 2 quantities we're trying to find. So the quantities you're trying to find are going to be your variables, the base and the height. That's what we're asking. Yeah, we're going to find those things. So now I'm going to create some equations. I'll call that step 2. Equations. So I'm going to get my first sentence from my first equation. So the area is 20. Remember the area of a triangle. Area of a triangle is 1/2 base times the height. So 1/2 the base times the height, that's the area. That's equal to 20. And for my second equation, I'll use the second sentence. The base, b, is means equals 6 less than the height, 6 smaller than the height. So basically we're going to take the height and subtract 6, right? The base is 6 taken away from the height. Right? You take the height and you subtract 6 to get to the base. The base is 6 less than the height. So I have these two equations. Now I'd like to solve them. I'd like to solve this situation. Step 3. So like last time, notice I have two variables, b and h. And I want to get this all in terms of a single variable. So what I can do, in place of this b here in the first equation, I can replace that with h minus 6. So I'll have 1/2 blank times h equals 20. And instead of putting a b there, we'll have h minus 6. We'll replace it with h minus 6. Now this kind of equation here has a fraction. And I don't like fractions, so I like to get rid of my fractions. How do I get rid of my fractions? I find a common denominator in LCD and multiply both sides by the LCD. So let's find an LCD. Well, really, there's only one denominator here, and that's denominator 2. That's going to be my LCD. And we'll multiply both sides by 2. I'll take 2 times the left-hand side, 1/2 h minus 6 times h, and then I'll multiply 2 times the right side, 2 times 20. So on the left side, realize that this is 2 over 1. So this 2 on top cancels with this 2 on bottom. We'll just have h minus 6 times h equals, and on the right side, 2 times 20. 2 times 20 is 40. And if we distribute this h through, we're going to have h times h is h squared minus h times 6 is going to be 6h equals 40. This is a quadratic equation, right? A quadratic equation is an equation where the largest power is a power of 2. We'll subtract 40 from both sides because you want 0 on one side when you're solving the quadratic. You'll get h squared minus 6h minus 40 equals 0. And this is factorable, right? This is a factorable expression on the left side. We can make 2 pairs of parentheses. This is all equal to 0. And we'll say, okay, h times h gives us 8 squared. And you can find 2 numbers that multiply to give minus 40 and add to give here minus 6. Those 2 numbers are minus 10 and plus 4, right? Negative 10 times 4 is negative 40. Negative 10 plus 4 is negative 6. And by the zero product property, we can set each factor equal to 0. H minus 10 must equal 0, or h plus 4 must equal 0. One of them must be 0 for sure. So first I will add 10 to both sides. And then on the other equation, I'll subtract 4 from each side, and I'll get that h is 10. That's a possible solution, or h could be minus 4. Now immediately we know that one of these solutions cannot happen because if you think about the feasibility of your height has to always be a positive number, right? You can't have a negative height. You have to have a positive height because height is actually a length, right? It's a distance. And distances are always positive. So immediately we can rule out negative 4, right? Height is positive. Or height cannot be negative, let's say it that way. So that means that the height here, the height is 10 centimeters. That gives us only one dimension, the height. Remember, we're also looking for the base. How can we find the base if the height is 10? Well, if we take a height of 10 and we plug it back into our second equation right here, We take 6 away from the height, and we get 4, right? 4. So I'll take that the base is the height minus 6. 10 minus 6. That means the base is going to be 4 centimeters. And there we have it. The base is 4 centimeters, the height is 10.